Hello, everybody. So it looks like we're very rapidly approaching the end of the semester. There's this week, and then next week, and then the Monday after that. So it's getting close to the end. So if you have past due assignments that still need to be turned in, please try to get those in sooner rather than later. If anything's closed, like any assignments that are already closed, let me know. I can open those back up. That way everybody can get full points and move on to the next class, because this course is a prerequisite for a lot of other classes. We cover a lot of things here, right? Sort of our basic tools of working with a computer, what machines are able to do, right? So how to work in binary code. I've talked some about storing data, and then we saw our constructs for programming or problem solving in general, the sequence that things need to go in, and we've got a lot of practice with that. That's one of the big things from this class that really only comes with practice, is putting together algorithms and getting used to the sequential structures of how algorithms go together once we break it down to the smallest steps. And selection structures, where we can make simple choices, basically yes or no decisions. Oftentimes we'll hear it said as in terms of true and false, but in normal everyday conversation, we usually use words like yes and no a lot more often than we use words like true and false. So it can be very helpful to translate things into normal English to help with understanding. We also saw reiterative structures, loops, and ways to repeat sets of instructions when things need to happen repeatedly. We've looked briefly at recursion, but really loops are the ones we deal with most often. We typically only deal with recursion when we have to, or if the problem explicitly lends itself to the criteria for recursion. That's been pretty standard since the 60s, when programming languages started having loops involved in them, and we didn't have to do everything recursively anymore. And we also looked briefly at invocation, modularizing our code, but it was just kind of preview in this class, just something you're likely to see later. But I guess the point is, there's been a lot we covered in this class, just kind of all over the place. And everybody that's taken any of the IT courses at Ivy Tech has to take this course, so we cover a lot of information. And as you progress down, each one of you progresses down your individual pathways, the parts that are important for what you plan on doing, you will focus more and more on those and learn more and more about them. Introduction classes are often like that. For some people who might be just starting out of school, the introduction classes are usually very broad and cover a lot of topics. And then later classes get more and more refined and focused on those topics, the ones you'll need for the particular things that you're doing. And then last week we started talking about arrays, where we can, instead of storing data, each individual data point in its own variable, because those names, we can run out of useful names very quickly that way. We can store the data points in a collection of them, have a big set of data points that we work with all at once. And then we use loops to loop through that collection, and I guess a starting point is a more efficient way to organize and work with data. We have a little bit more to go over about that tonight. That's the main topic for tonight, and the next part's not going to take all that much time. So I wanted to start off with this little spiel that I give in every class that I teach. Everybody in this class has some sort of IT-based plans, right? You're going somewhere in the IT field, maybe hardware, software support, cybersecurity, maybe you're heading to software development, but your plans are probably somehow related to being an IT person, which is a desk job, right? That means work is going to involve mostly sitting at a desk. And sitting at a desk is kind of bad for the human body. Our bodies are very dynamic dynamic things. They're at their best when they're moving. An example I often refer to is like construction workers. Right? There's a lot more places where little injuries can happen on a construction site, or unfortunately sometimes big injuries, but in general, a construction worker through their working career is going to have a lot more little injuries than an IT worker sitting at a desk, right? Than a software developer sitting at a desk writing code for an entire working career. But all in all, once we get to retirement age, that construction worker is going to be in overall better shape because they've been doing stuff with their body the whole time. They've been moving and active. And human bodies are very dynamic things. Sitting at a desk is kind of a very bad thing for the human body. It takes its toll on us. A different kind of toll than like hard manual labor where there's a lot of chances for injuries and stuff, but those little things that aren't quite great add up over time. I meant to bring I forgot to bring one of my props in here. Let me grab this real quick. So to start with, let's talk about a keyboard. I apparently don't have multiple keyboards anymore. I looked around, checked the closets and stuff, and I've apparently thrown all the old ones away. I use laptops all the time. Like my desk has 3 laptops sitting on it. But the Chromebook here is sort of a standard keyboard, right? If we look at it from the side, it's very flat, which flat, square surfaces, that's very unnatural. And the keyboard's no exception. Using this sort of movement or performing this sort of movement over and over again for years in a working career can really wear out parts of our body. In particular, one that y'all probably heard about is carpal tunnel syndrome. Carpal tunnel is the tube in your arm that all the nerves from your hand go through, kind of binds all the nerves together. And when that tube gets damaged, my understanding is that like your brain just constantly receives a pain signal from your hand. So it's like you always think your hand hurts is what happens. And something like a keyboard tends to cause that. There are little things we can do to make a difference. And if you're going into IT career, you want to think about some of these things. I always like to take 20 minutes or so and talk about this in every course. First off, with a keyboard, if you haven't heard it before, you do it kind of like a piano. So instead of swiping down to press the keys, which does work, you want to sort of have your fingers bent or somewhat relaxed and push straight down as much as possible. So like hold your arm up, which is another little thing that can help. Just lifting your arm up so that you're not at a straight on angle can make a difference. If you kind of feel your forearm muscles here and move your fingers in different ways, you'll see big differences. Like if you're flat and moving your fingers up and down, you feel a big difference than if you raise your arm and move your fingers straight up and down like you're typing on a keyboard. So those little bitty arm rests, those make a big difference, especially if you're going into an IT career and going to spend 40 plus hours a week sitting there at a keyboard. Little things like that can make a big difference. They also make better keyboards than the flat shape. That's why I wanted to grab it. Does anybody know the origin of the QWERTY keyboard? The position of our keys, where that layout came from? So the setup there is originally from the old typewriters, like the really old typewriters back in the 1920s to 40s era, where there was actually like levers that all spun up from a different spot whenever you push the key, and letters that were very likely to be used next to each other, things that there's common combinations of, were intentionally moved apart. Right? Like T's and H's. They're both very common letters to use in English, so they're near each other. We'll use our index finger for both of them, but they're separated just enough so that the combination wouldn't cause the levers to get stuck on each other. The levers, if you type too fast on those old ones, the levers right next to each other could get stuck on each other. So it's kind of spread out that way into an inconvenient pattern to use. The biggest problem, I guess the actual design of it is too slow as down when we're typing. So there are other configurations for our keyboard, which can be handled in software. You can just load in a different configuration for your keyboard, and as long as you remember what button goes with what label, it still works fine. But that flat surface is very unnatural for our hands, right? If you hold your hands out and relax them, they go like this, right? The keyboards needs them to be like this, where all our fingers are kind of at the same level, which takes a little bit of adjustment. But if we just try to relax, our hands look something more like this. So I'm pulling up a couple pictures here of things to look at. Ergonomics. Well, I'll start with just the basic. Have you all heard the word ergonomics before? It's typically used in terms of productivity, increasing productivity, but basically it's doing things around the human body instead of just working with the tool. So that's kind of what we're talking about here. I always like to come to the Wikipedia page. There's this picture that makes a good starting point. The position you're in and stuff. It's a very old picture, obviously. There's a couple things that could be better. But you always want to make sure you're looking straight at your screen. You don't want to look down at your screen or up at your screen, because that will obviously, over 20 years of doing that, 40 hours a week, that's going to cause some neck issues, constantly looking down or up. Her arm position is not the best one here. You should really raise, her arm should be raised up from the keyboard. It looks like they have it almost flat. Well, you can feel the muscles in your arm doing this as opposed to doing this. You can see there's a big difference, and that sort of thing wears on you over time. A good chair makes a difference. Y'all can do some research into that. Just start with the word ergonomics and kind of look around, see what you find. It's just something to keep in mind, because if you're in this class, I assume you're planning to spend 40 hours a week at a desk, which is kind of bad for the human body. So I was talking about the keyboards, and they make better keyboards than just these flat ones. So different shapes. I'll just pull up some images here. And the biggest factor is what I was pointing out a moment ago with, if you hold your arms out and just relax it, that's really what you want to look for, is the relaxed position. You want to be relaxed position as much as possible. It's kind of hard to see on some of these. They do raise up. These are kind of the extreme case where you're typing like this. It's split in half. Are there any? Oh yeah, that one. You can kind of see that it curves up in the middle. It's not just split in half, but it's raised up so that it fits the natural position of our arms when we relax. That can be much better for the body over time. Help prepare like carpal tunnel. Split keyboards are also really nice too, because then instead of that forcing your hands to fit that machine, you can position things in the best spot for each one, right? Put your left arm in the best spot for your left arm, and your right arm in the best spot for the right arm, instead of just trying to find a decent spot for everything to go at once, everything to go together. The split ones. There's one other picture I always like to look on here, which is taking forever to load, and I don't see any up at the top. But these are still that sort of traditional. They're not very far from the traditional keyboard, right? We still have that QWERTY layout, QWERTY, the standard typing things. You just move the keys into different angles and positions where it's better for our arms. And if you're planning on doing this for 40 hours a week for years, you might want to think about, keep things like that in mind. So the idea of the right tool for the job instead of just any tool. And over the last year, there have been a lot of new innovations. A lot more things have shown up with the split keyboard options, which works really, really well, especially with some stuff we'll see in a few moments. Yeah, to avoid that right there, to avoid that wrist pain, and hopefully you put off carpal tunnel, which is just constant pain. So you can see there's some very strange layouts. This one, they have better pictures of that over here. It's hard to see in that picture, but that does curve upwards. So it does have that middle thing, and then it's got a flat spot on top that you can reach over and use. Some good things. I don't see the picture of the one I was on, this one. And then these right here, that looks very strange, right? It's a long way from the traditional keyboard. They have different layouts, but that circular pattern, hand doctors, what's the word? Is it orthopedic? Orthopedic experts, the actual hand doctors did research, and so this wasn't some artist that just had a strange idea. This is what actual hand doctor experts did research and figured out was the best shape for a keyboard. But obviously, to use that, you'd have to completely learn to retype, and then a normal keyboard would seem weird if you were at anybody else's machine. But the idea is that instead of trying to move our oddly shaped hands, right, all of our fingers are different lengths and kind of point off at different angles, have different muscles combined. Like you've probably seen that thing, if you bend your middle finger in, your ring finger can't really move on its own. But there's different combinations. It's not a square, it's not square, right angles, flat surfaces. It's a natural shape. So instead of trying to fit that odd natural shape to a square keyboard, the idea on those round ones is we kind of start with that center, like a center thing, and then spread outward to reach all the keys. So it fits better with the hand. And over years and years and years, that stuff can make a bit of a difference. Along with the keyboard, there's another big one, right? You're gonna be using one of these things all the time. And I always like to hold one of these up when I talk about these videos. Let me stop the screen share. Because here I'm holding it so y'all can see it, which you can kind of tell it kind of fits the natural shape a little bit. But one thing, the way I'm holding it here to carry it would not work for using it. I have to hold it and use it in different ways. My hand lays flat. They've gotten a lot better over the years, but it's still that basic box shape. Has anybody ever seen the original mouse? Or pictures of that? Seen the story of that? I'll pull up a picture of that. There it is. So yeah, not the one from the Macintosh in the early 80s that first popularized it, but the original one, the one that's in the Smithsonian where the actual inventor created it. He had the idea, and in his office, he had this little wooden box that was big enough to hold all the pieces he needed. So he didn't really even intend for it to stay box shaped. But that's what we've stuck with, right? It's put the components in that box, and it's kind of stayed that way the whole time. And in the box shape, some of the modern ones have gotten better. But just like I pointed out with the keyboard, relaxed position, this is not the relaxed position, right? where these two fingers are just off to the side doing something. Then we use these two fingers and maybe the thumb over to the side. It's not really a relaxed position of our hands. That you can see what it is if you just hold your hand out and let it relax. It's going to kind of turn like that. And they do make a mouse that follows that shape. Which again, just like those stuff, if you're spending long hours, like an entire working career using a mouse, that bad shape's going to add up. Oh, I guess you can see it in this picture right here. See how it's like the mouse turns sideways so that it fits the natural shape of our hand, the natural relaxed shape of our hand, to help with some of that long-term usage. These are kind of new, so I don't know much about them, but I could see that being convenient. But at the same time, I'm kind of curious about having this motion all the time. So I don't know for sure about that one. Those are kind of new. But the vertical mouses can help with carpal tunnel and other arthritic issues that come from forcing our hand into an unnatural position for 40 hours a week for 20 years. Trackball mouses are also very nice, like this, where the mouse stays stationary and we just move that ball. Because there are a couple joints on the human body that are not really joints, the joints that wear out, but the muscles will never get tired. And one of those happens to be our thumb. We can move our thumb forever and we'll never wear out those muscles. The bone will wear out before the muscle does. So these stay stationary, and then there's that ball by the thumb that we use to navigate around. Artists and designers like those. Those are very popular with artists and designers because you get a lot of control over them. But there's lots of different shapes, and engineers are constantly working on new ones. So you want to, if you're going into IT and going to be sitting at a desk for a while, you want to keep things like that in mind. Make sure you have tools that aren't going to damage your body just from using them. And then I guess the final point there is sitting at a desk, right? The thing about the keyboards that I pointed at and the mouse I pointed at were the natural shapes. Relaxed position of our hands and natural position, the natural shape of our hands, and working with that instead of modifying that shape to fit something else. And a desk is a great example of that because desks are usually great big rectangles, right? Rectangular cube things, and that is definitely not a natural shape. So things like a comfortable chair and a good layout for your desk, those make a difference. But does anybody know what the actual best position for humans to work in is?
Is it standing up?
Standing up's pretty good, but that still wears out a little. And it's kind of like standing up, and that's the zero gravity position.
Yeah, I work best when I'm laying in my bed, just, with, just real comfortable with my covers over me and my eyes closed.
Yeah, so there is something called zero gravity chairs they put in cars, but like this right here is zero gravity position. So I don't see that being safe in a car. So I don't know what the car one refers to. That's probably just comfortable or something. But this position right here, which is kind of like standing, right? Like you said, point out, Larissa, it's like standing, but a combination of what you and Jacob just said. It's kind of like standing, but you take the weight, you don't have the weight on your feet either. You're in that natural position for a human. And you can do some of those things.
It's only $12,000. That's awesome. I'm like,
yeah, some of those get expensive.
How much is the Scorpion right there? Yeah, what is
the Scorpion's not $12,000. That one right there is motorized and folds up.
Or wait,
so
this
it like
one right
folds into a chair, and when you sit down in it and hit a button, all that stuff like comes out into place.
What about the zero gravity workstation 7? What's that one?
That one might not be as bad. It's probably
looks-
still a little expensive.
That thing's pretty cool. Look at that. You got a little table. It rolls around. Maybe if you were like,
Yeah.
I feel like people would think you're like, you know, maybe you had some sort of a handicap or something. Maybe, I don't know.
Yeah. I don't know. You would definitely look really cool working in those in an office, but that's kind of the best position to work in. Obviously, these pictures start with the expensive ones. Something like that would probably be cheaper. And then that one just has like the car seat lever where you pull the lever and then it folds, the whole thing flips back. Or they make some zero gravity chairs. They're kind of expensive, but IT people usually make pretty good money. Yeah, so they also make like just little chairs. Oh, that's an expensive one. There's a cheaper chair. Yeah, so like $300 for one of the good chairs that folds back and has all that. But that is the best position for a human to work in. Just something to keep in mind if your plans are to spend your working career at a computer. You might want to do what's the stuff that's good for your body. The things like this would be really great. You could put like this one. Jacob pointed out, you have those tables and that wide work area, so you could put the split keyboards off on each side where you're really comfortable, and a vertical mouse so you're not wearing out your arm holding it in an unnatural position, and different setups to keep in mind. Not exactly cheap. I just always like to mention that at some point in these IT courses, because if you're planning on spending your working career sitting at a desk doing IT stuff, it does kind of take a toll on its body. So different things to keep in mind. Gym memberships and stuff, but y'all have heard that. Y'all have probably heard that whole spiel before. Exercise, about exercise being good. So just things to keep in mind, because sitting at a desk is not good for the human body. The human body does best when it's moving, when it's up doing stuff. So just some things to keep in mind. So now back to our topics, unless somebody had any questions about that, or let's look at some other pictures or something. But y'all can Google, start like Google ergonomics and look into that stuff. Ergonomic keyboard, ergonomic mouse. That word's usually involved. And if you Google that, you will see other keywords to search for and find out that stuff. More of a long-term thing to keep in mind. So for us tonight, we were talking about arrays the other day. And one thing about arrays, especially at the introduction level, it's hard to see the usefulness of it. Is whether it's a class like this at a college, or you're following tutorials online on Udemy or something, or one of the 3-week coding boot camps. When we first get introduced to arrays and lists and all of our data structures, it's really hard to see the usefulness of it because it's at the introduction level, and at the introduction level, our problems are only going to use so much data, right? Or they're only going to get so big as we're being introduced to this. And oftentimes it doesn't really seem like it would have been any more or less work just to use different variables. But in the long run, they will be kind of useful. And the next aspect of it is another one that's probably a little more useful for people that aren't directly going into software development, the one you'll see more often. And that's going to be multi-dimensional arrays. And I just use the word multi because the concept we're going to talk about expands very big, but we're only going to talk about 2 in this class. And that's the one that I was just referring to, that if you're not going into software development directly, and those who are, you'll still come across a lot. So we saw nesting, right? We saw that before we would nest selection structures and put an if-else structure inside of another if-else structure. It's so common that that's abbreviated in pretty much all of our languages. There's a standard abbreviation for putting that together in a certain way, but we can put a selection structure inside of another selection structure to make multiple choices, give our flowchart different branches, multiple branches to flow down. Or loops, we could nest loops inside of loops. I don't think our example in class did that, but we saw at least one example where we put a main loop. So that I think on menu-driven software, where our program would keep running and running and running until the user was finished, until the user typed the word exit or entered a queue to quit or whatever we set it up to accept an end of program instruction from the user for. But it would keep running and running, and then inside of that main loop, if the software itself, if its purpose required us to run loops, then we'd just stick loops inside of that. So we can nest loops inside of loops. We can do a similar thing with arrays. It's a little different because it's not quite the same structure, but conceptually, that's a good way to think about it. Is we saw last Wednesday, I can't remember what day we meet for a moment there, but we saw last Wednesday where we can put a bunch of data into this big set of things. Can we expand that further and put a bunch of arrays inside of an array? And yes, we can. That's what is referred to as multidimensional, an array filled with arrays. So I'm going to draw a picture here. We've seen the stack heap diagrams a few times. Oh, somebody's coming in. Oh, I didn't think she was going to be here tonight. So last week when we looked at arrays, I kind of drew a picture like this and went in over it. It's a heap where it represents our RAM. Say this references this collection of things where each one of these elements is however many bits are stored in our data. Maybe it's an 8-bit integer, so each block we have these 4 different 8-bit integers, and we're keeping them all as a collection that we refer to this way, and then use square brackets with some sort of index to refer to each particular one. Element 0, element 1, 2, 3, or 1, 2, 3, 4, depending on which language we're in, because some of our languages start at 0 and some of our languages start at 1, so we have to be careful with that. But that's putting our simple basic data into that array. Can we expand that just like nesting with our selection and loop structures? Can we expand that and put an array in an array? So I'll call it A2 here, just because, well, in your code, remember, spell out variables, but when we're writing it by hand, like making pseudocode and plans, or in my case here, writing on the board, or hopefully for some of y'all following along with taking notes, it takes a minute to spell things out when we're writing by hand. So we abbreviate by hand, but we'll just call it a second array. And again, that's going to point to some collection of elements. But in this case, each one of those collections might be another collection. So each one of these is like the 8-bit integer. And then this, I can do this without crossing. And this one points at that one. And then we have another collection down here. And I did intentionally make that a different number of elements. That wasn't being quick. They do not have to point. They do not have to be square. But we have an array stuck inside of an array. And thanks for all these pictures. I think y'all can see where that's going. And we have a whole bunch of elements in this one. So this second element in our initial array points at a separate array itself, or holds a separate array itself. So that's what the actual picture looks like, but there's kind of a better way we could draw that. So I'll put that over here. So point to our initial array instead of having it here by itself, wherever it's stored in memory. The accurate representation, it makes a lot more sense if we were to turn that sideways. How many did I put there? 1, 2, 3, 4. So that this refers to this array, and we turn that sideways, then each one of these other arrays kind of go out the side here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or the second one has 3 elements. 1, 2, 3. 1, 2, 3, 4, 5, 6. Yeah. And that picture might look a little bit more familiar to you. If it was square, it would look a lot more familiar to you. But that's sort of the way we think about an array filled with arrays. Turn our initial reference sideways, and then bring the others out so that it essentially makes a table. We end up with rows and columns of data, and just a big table of data. So multidimensional, two-dimensional arrays are very, very useful because it allows us to organize our data into tabular format, which makes it a whole lot easier to work with and to visualize what's going on. And then for the multi-part in the name here, that could continue, right? We could put an array in each one of these, which for a three-dimensional array, we could picture a table with then things stacked up on the table. If it gets higher than 3 dimensions, it's kind of hard for us to visualize, but the process could continue. We could keep putting arrays inside of arrays, or lists, or stacks, or heaps, or whatever data structure we're working with. But typically, we mentioned last week, array is our go-to terminology. That's the one we usually use unless we're wanting to be specific. Everybody's seen tables before, right? And working in nice, organized tables. That way we can keep lots of data together in a similar fashion. And that's pretty much the only concept for multidimensional arrays. That keeps building and building and building. But for us in this class, we're only going as far as 2 dimensions. If you want to mess around with it, those proceeding further into software development, you can try putting some 3-dimensional arrays together. It follows the same pattern. Oh, I guess there's a notational note. So there's 2 common notations. If we just have an array, I guess I'll put that over here because I filled up the whole board. So I'll call it ARR for abbreviation. We use square brackets with some sort of index to refer to which element of that array we want. So it's like we have our reference name, kind of like a variable, and then we added the square brackets on to say there's a bunch of things in that connected to that variable, to that reference. That pattern can continue. So I'll do ARR2, and we have the square brackets. I'll put an I in there this time to stand for index, to say, well, this is an array, but it's an array filled with arrays. We can add another set of square brackets with a second index. I'll use a J. It's pretty common to use I, J, and K for, we have 3-dimensional ones. I stands for index or integer, however you want to look at it. And J and K are the next couple letters of the alphabet, so it just makes sense to follow them up. But that way we have an array filled with arrays. And so sometimes we'll notate it this way with 2 sets of square brackets. And another very common notation is to just strip out those internal brackets, all these ones in the middle, and use a comma separated list. Or you might see it notated as ARR, an opening square bracket, and then we feed in a comma separated list of indices, and then the closing bracket, just to avoid all those internal, the mess of internal brackets there. So you might see it written both ways. And for us here, does anybody have a guess which way we're going to see it? Between Python and Raptor? Have you looked ahead at the homework? So Python uses this notation with 2 sets of square brackets, and Raptor, which is originally based on Perl, uses this notation with a comma separated list of indices inside 1 set of square brackets. So we'll see both notations in this class. I guess that's one advantage of this, the change this semester in using Python and Raptor is we keep seeing those similar but different things, right? Like in loops, Raptor leaves the loop whenever we have a true condition, and Python stays in the loop when we have a true condition. So we see both ways. And same thing with arrays. Our 2 most common notations for multidimensional arrays, multiple sets of square brackets, or a comma separated list in 1 set of brackets. We'll see both of them with the way this course is set up. And I guess the last thing to mention, kind of part of the example that I was getting ready to walk through, is we saw last week when we had a 1-dimensional array that we just use a loop to go through it. I don't have the other props, I had the props for the ergonomic stuff with me today. But last week I had the backpack in, and remember, we treat it like a collection of things for a school day. Right? Our data gets treated the same way. When we need something, we just dig through there or loop through there and check each item in the backpack until we find the one we need. And we do the same thing with a 1-dimensional array. So for a 2-dimensional array, we would just nest some loops to go through it. Because we need to walk through it twice. We need to walk through our main loop. Our main loop our outer loop goes this way through this one, or this one in the actual picture. And then on each pass, it needs to have a loop nested inside it to walk through all of these. So we have the 2 nested things. And our examples for class will be a nice organized table. I explicitly did that as a jagged table. That's what we call those when we have a different number of columns in each row. For your homework and the examples in the class, the tables will look like this, nice square thing, so that we can say on each time that they'll have the same number of columns in every single row. But that is not a requirement. That just usually shows up when we're organizing data. Does anybody have any questions about that concept? Hopefully that flowed very naturally from what we did last week.
Could you show an example in Raptor format to utilize that?
Yes, that is what we're getting ready to do. I was just making sure the concept there makes sense. It's kind of like we already saw with nesting. Typically, we don't use the term nesting for arrays, but essentially it's essentially the same thing. We're putting one of our structures inside of itself, a similar structure. So let's look at an example unless somebody had any questions, but hopefully the basic idea there kind of flowed naturally from what we saw. So I'll do Raptor first, and then we'll look at it in Python. There it is. So we talk about tables, and that might make you think of like databases or spreadsheets where we organize our data that way. So a lot of using this should be very familiar for that. The new thing is going to be how we work, how we have the computer move through it. Right? Because when we see it in a spreadsheet, a human kind of knows what to do with all those rows and columns of data, and it feels very natural. So just like we've seen over and over again, sort of the main point of this class, the thing we practice over and over with the homework, is breaking those steps that a human can do down into instructions or algorithms so that a machine can do it. We have to work in loops and things like that. So my standard example in classrooms is just for data is a few made up name, age, and town. Name, age, and location, just some simple data to work with. So we'll make a little table that way. So we have some multiple arrays to work with. And I will start by just filling it in. So in Raptor, we use the notation with one set of square brackets and comma separated values. So I'll just call the table people. It's my standard example, name, age, and town. And whenever multiple examples are added, add like favorite food and stuff. But like we saw last week, it's an array. It's a collection of things. There's a bunch of them, so we need square brackets to say we're referring to an index. And in Raptor, we start at 1. So our very first one, 1, 1, will be somebody's name. I'll put Bob. And then people, so we look at those numbers like row and column. So we would put all of Bob's data in the table. Maybe I should put the table that we're making on the screen real quick so we can see what's going on with that. Oops. Or not on the screen, on the board. Is it okay if I erase this? We're already past all this, so.
Not really, but I'll catch it up. Seriously, go ahead. I'll catch it up.
Oh, okay. Yeah, so that's just kind of a picture of a pictorial representation. I like to draw pictures because humans are a very visual species, right? We
Yes.
base a lot of things on appearance. So when we translate into a picture, hopefully that helps with understanding. So the table I was thinking about making is one that's going to have just 3 columns of data. We'll have a name column, an age column, and a town. I'm just going to make up some people to put in here. And then each row will be a particular person. So this first one might be Bob, is 25 and lives in Sellersburg. And the second one might be Becky, is 44 and lives in Jeffersonville. Room there. And those labels will be important. The box is empty. We'll come back to those, but each horizontal row is an array of data. So those are indexed 1, 2, and 3 for us in Raptor. And when we repeat this example in Python, it's going to be, they'll be indexed by 0, 1, and 2. So again, that we'll want to pay attention to what the language we're working in uses. And then all of our columns are also an array. So they'll have an index going down this way, 1, 2, 3, and so on. So we have those 2 indices each time to deal with. But that's the data I was had in mind. Does that make sense? We want to build up this table in a program. So then, in the past, people have said this one feels a little more comfortable because we start with variables where they're just all scattered points of data, right? That's like a big armload of stuff. There's no organization to it. Could be anything. Then we see arrays where we start to collect it. But here it's more, it's like a nice organized table. So we can see how all our data is. We can easily visualize how our data is held and how it goes together and stuff with once we get up to 2D arrays. So that's the data that I had in mind, and I'm just going to kind of make that here. So our first row is Bob's data, and the first column is his name. The second column will be his age. So again, this people 2-dimensional array, the square bracket, because we need indices since it's an array, or we saw last week that technicality, it's a list, but list has a lot of preconceived notions with it, whereas array is more specifically a computer term. So we're still in the first row, but we're in the second column now. And what do I write on the board? Bob's 25 years old. Oh, and I got to save. Looks like I'm in the right folder. And then we can finish out Bob's data this way. So set people, the first row, the third column to Sellersburg. So as you can see, filling this out is probably going to be just like if we put it in variables. And the difference is the organization. Then once it's stored there, we don't have to come up with meaningful variables for everything. It's all in that tabular format. We just have to remember that the first column is names, the second column is ages, and the third column is towns. And then we just keep adding all our data in this way. So once again, the people array. So we finished the first row, so now we're on the second row. In the first column, maybe Becky. Then still in that 2-dimensional array or table, makes a lot more sense. So the second row, the second column of that is the age. So maybe Becky's 46. I can't remember what I wrote on the board. I guess I could have turned around and looked, but I'm just making up this data. And then finally, the town she lives in. So that table in the second row and the third column has our town data. So maybe Jeffersonville. Yeah, so you can see it takes a minute to fill up the table this way. If it was coming from a user, you would just set up some sort of input. Or what we'll see next week or starting Wednesday, we'll save data to a file so we can retrieve it every time. That makes this a lot easier because then we can store it in tabular format in a file and then read it right back into a table. But since that lecture comes after this lecture, this first one, our first example here is just a whole lot of filling out data. So we have 2 rows, so we're on the third row now. The first column is going to be somebody's name, I'll say Sally. And maybe Sally is so the people table, third row, second column is the age. So maybe Sally is 14. And then finally, same table, third row, third column. Maybe she lives in New Albany. So obviously that process can continue for however much data we have, however many rows and columns you want to make your table. Just need the two indices, and in Raptor, it's one set of square brackets with a comma separated list. I'm gonna go ahead and run this real quick. Just let it fill in. And you'll see over here in the watch window, probably need to make that a little bigger. It created that array, a multi-dimensional array. We can tell if the square brackets have a comma in them. If we expand that, we can see each one of our rows has the square brackets. So each one of our rows has more data in it as well. And since we have two arrays, we'll need to nest loops in order to walk through them. We'll need to walk through our first index, and each pass of the first index, 1, 2, 3, we need to walk through the second index each time. So that means we'll need to nest some loops. So we'll bring in a loop. And then we'll just kind of walk through it. I haven't done this last semester. I think Raptor doesn't like if we use, we'll throw an error if we try to use that length on both selections. I'm just gonna put it in here and see what happens. So I think we can go until, I better create an index first. So just like we saw last time, every time through the loop, we need an index. So we'll set index, I'll just call it I, the one beforehand. And then this is for this outer loop. Maybe if I highlight the inner loop, that'll, yeah. So the loop that's in blue has the outer index. That's our rows of the table. So we create that index. We'll go until I is bigger than the length of our people array, which is a 2D array. So I think it looks at the outside one. I haven't done this since last fall. I probably should have checked this afternoon. So that might crash and we'll just adjust it. There's different ways we can do that, including a shortcut I'm just showing in a moment. And then before we come back around the loop, we want to remember to set our index I to whatever was stored in I plus one more. That way we don't enter an infinite loop. But on each pass through that loop, we're going to loop through an array again. So we need to do those same three things. Once we know we're still in the loop, we'll set this second index. I'm going to call it J. Okay, yeah. In the little box, the font, you can't really tell the difference between I and a J, but we can call it J. So once we know we're going through that inner loop, we'll set our index. We'll go until J is bigger than 3. That's when we're done. So it'll go 1, 2, 3, then increment to get to 4, but then there's no more data. So I just want to check your conditions carefully, and sometimes it helps to talk through them. It's actually a common strategy called rubber ducking to just talk through the problem. The strategy is to like hold a little rubber duck, an inanimate object, and explain the problem to them. And oftentimes in doing that, even though it's your own voice that you're hearing it will help lead to the solution. Or if you don't want to talk to a rubber duck, pets are great for that. Like explain the solution to a dog or a cat or a fish, and just talking through it will often help you realize what's being overlooked. Oh yeah, but then our standard conditions. So we're gonna, before we finish the loop, we want to set whatever was in J to one more. And on this first one, I'll just print, I guess I'll just print stuff. I'm going to print people. I'm going to print whatever's in the I, J table cell of that two-dimensional array or type. So first time through, it'll print the name, the age, yeah. So the name, the age, the town, and then it'll go down to the next row and print the same thing for each one. So kind of a trivial example. Hopefully that makes sense. We fill up our array, which takes a little bit more at this point, but when we see writing files on Wednesday, starting Wednesday, it's much easier to keep tabular data in a file and then read it in from there. We just do 2 loops instead of 1. Or if we have a higher dimensional array, 3 or 4 dimensions, then we would just walk through those in the same way. So I go ahead and run this. It'll fill up all that data. Oh, okay, yeah. You can't use the array, so we need numbers. So we'll go until I is greater than 3. In Raptor, we have to do it this way. In some of our other languages, there's shortcuts. It's a little bit different. I hadn't seen that since last fall, so I remember there was something about it. You can see on each pass, it just prints out the next item from the table. Actually, I can make that look a little bit better. Is it almost finished? Okay, yeah. So first thing I'm going to do, I'm going to come up here to the top. So the standard debugging process we've seen many times, right? We ran the program, it made it through there, but there's some improvements that can be made. So first thing I'm going to do is clear that console to get all this junk from the last pass out of the way. And then what I'm noticing is we set that up as tabular data, which means Bob 25 Sellersburg goes together. So it'd be nice if we didn't have a line break there. And then we had a line break and Becky 46 Jeffersonville goes together and put it together that way. So to do that, we're going to need to make some sort of decision about whether we have a line break or not, right? If we look through here, if J is 1, that's the name, because all these are the inner loop. If J is 2, that's so I is 1 and J is 2, that's the name. I is 1, J is 1, both of them are 1, that's the name. When I is 1 and the next pass through, we'll increment get all the way. 2 is the age, 3 is the town. So really, we don't want to line break in those at all. Maybe instead of a line break, I'll just put plus space. I'll just print the name and then a bunch of spaces to kind of split that up. So when it's 1, we print the name. We'll come back around. When J's 2, we'll print the age. J's 3, we'll print the town. We'll come back around. Then we're done with the loop, but that's all our data for that row. So when we leave the loop, that would be a good time to print a line break. So I'm going to come down here and output an output down here that only has that in current line checked. So that puts in the line break. And I think I forgot to uncheck the box over here. And uncheck that box there so that we don't have any line breaking. Does that make sense? Everybody follow what I was doing there? Once I saw the data, what happened on the first run, just kind of walk through it a little piece by piece and check it and think through what's happening in every situation or at every point in the code or algorithm or whatever you want to call the flow chart, and think about where it needs to happen. So after we print out all of the first row, then we leave that inner loop. We make a line break, increment I. We come back around, reset the second index, then loop all the way through the third row. So that should make our data look a little nicer for the output. Once it loads, starts looping through there, you can see the data is printing in rows and columns now. As much as this will fit on the screen. If I make this a little wider, there it goes. That looks like rows and columns. And just makes it look nicer. Does that make sense? Everybody kind of see what's going on with that then? Or does anybody have any questions? Maybe I should ask it that way.
I got a question. How about headers for that? Would you create that in that program or?
Yes. Yes, we can print headers for that.
And could you put that whole thing into its own function to call?
Yes. Yes. It's split it up into pieces. So
Well, yeah, from the main to create a function to call.
I'll go ahead and do that. So, well, I have to zoom out. So if I take all of this, zoom out where I can see all of it, take all of this and cut it out of this and create a new function call, I'll just do a new subchart instead of a complete separate procedure, but it would behave very, very similar. Let's call this load data. We'll call this function called load data. You have to create a new one and then paste in all that. So the easiest way to add headers in would probably be to put them in the array, which obviously you would want them as the first thing in the array. Like row 1 would have the name, age, and town, and then we can just refer to them that way. Or we can print them out. There's multiple ways. I'll select all this, cut that, and put that in a subchart called print data. Just create it. Just to keep it more organized. Is that what you were thinking about, William?
Yeah, something to break it down into parts easier to manipulate. And like I said, make a better output.
Yeah, make it see what's going on with it. Yeah, so then one subchart or module loads in is just for loading our data, and one's just for printing our data. It keeps everything much more organized. And for an output, we could just print those labels. The easiest way I would think would be to put them in the array, which I mentioned briefly the other day, that when we're mixing SQL, structured query language, from databases with other languages, we often have that offset. And that's because SQL does that. It uses index 0 for the label of the columns, and then the index 0 on the rows holds some other metadata about the table. So that language does that by putting the labels in the array. But since that was already full, that would involve changing all the indices, because we want index 1 to be those labels. I'm just going to print it out. So name, and then I'll put a few spaces, age, and a few spaces, and then town. So I'll just kind of print out the labels and then do those subcharts. You see it filled it up, and now it is looping through, and we'll make that but that way it's not flashing. Yeah, and still kind of works the same. There's better ways to line that up, and obviously I just mentioned 2 ways to do that. I did the easy way to get the labels on there this time, but it would be better to have those labels in our program somewhere. And one other thing that might make it really useful to work with, so like here on our data, if I zoom back in here, I was going to show this point in a few moments, but this row 1, column 1 has the name. Down here, row 2, column 1 has the name. So the column data is always named. So if we were doing a lot of manipulating that, it might be really, really useful to have the number 1 stored to a variable called name. So then if we wanted, we could just loop. I'll do a second loop here. We could just go from, I'll bring in another index. Start at 1. Go until index is bigger than 3. And each time just print people, whatever row we're on. So we'll loop through all the rows and print that name. Because that's just a variable. That's just another way to say the number 1, which is very, very useful in this situation. So you might want to keep some things like that in mind. Whenever you start organizing your data, you could use those labels explicitly as integer variables holding integers. Then you have a really nice, clean way to refer to the spots in the table. And once it gets back to the other part, oh, I forgot to increment the index. So we're going into an infinite loop here. Yeah, and the normal debugging process.
Beware the endless,
What's that?
beware the endless Bob.
Yes, those happen. It's our normal process. Put together what you think is going to work, run it, and see what goes wrong, and then fix it. I'll run it a little bit quicker. So you see on that last loop, when it doesn't go into an infinite loop, it's, whoops, everything's moving on me. It's using that more meaningful way to say 1, because we only wanted the first column each time, but we've already seen a very useful way, a very handy way to put the number 1 to a useful term that we can use over and over again. Does that all make sense? And the cleaning it up and organizing it is definitely a good thing. It helps to keep track of everything. Just like we saw with the arrays last week, we have multiple indices, which means we need multiple loops to walk through them. And a similar thing when we do it in Python. Which is already 7:15. So you want to take a break and then we'll look at the Python one after a break. I know I'm getting a little thirsty.
Yeah.
Okay, so let's go ahead and take 10 minutes. I just happened to glance at the clock there. And I'm going to go grab a cup of coffee, which I think my coffee's been sitting up there on the warmer since like 3 o'clock. So it's probably not good coffee, but I'm getting very thirsty. So 7:14, we'll meet back here at 7:24, and then we'll go through see that same thing in Python.
Can you answer one question real quick?
Yes.
Okay, right behind you on the board,
Uh-huh.
where it says the arrays, and then the second one down. Can you read that for me? ARR2.
Yes. So that's a notational thing.
Mm-hmm.
So instead of one set of square brackets for an index, when we put an array inside of an array, we'll use a second set of square brackets.
Okay.
ARR2, and then the first square brackets have an I in them, and the second square brackets have a J in them.
Okay.
And if we have more, like if we do a 3-dimensional array, we would add another set of square brackets with a K in them.
All right.
So multiple ways of notating multi-dimension arrays. This is what we'll see in Python right afterwards.
Thank you.
Any other questions?
Not at the moment. Thanks.
Okay, so let's take 10, and I will see y'all at 7:25.
Sounds good.